So today, last class, let me think about, oh yeah, last class we just discussed, where is so last class we discussed Q, if you recall. And we discussed all of the concept and the implementation using an array. So for Q, the feature is first in, first out. Okay, so we need to remember this. And the major operation that we also learned is add a new item. But be careful, okay, for Q it's at back. And the Q is we can access at both ends. So that's different from stack. You can only access at one end. Is it? So when we add at back, and we call the operation in Q. And we can also do remove, is it? So we remove front item. So that's at front, is it? So we call that operation DQ. Okay, and we can also get the front item. So that operation we can call it front, is it? And the last class we also discussed the implementation. Using circular array, okay. And when we use a circular array, then we can avoid the shifting issue. Via the regular linear array. Okay, so that's all we discussed. Last class, the concept. Okay, so today let's then take a look regarding the circular array implementation of Q, okay, how we implement it, okay. So let's take a look. So we define our own Q class, and we are going to also let this Q class support clonable interface and iterable interface. And we will also see this iterable interface quite useful, okay? And for the Q, if you recall, when we implement using array, we need both front and back index. And also remember, okay, for the front index, it points to the front item. But be very careful, okay, for the back index, it's not the back one, okay. It's a point to the next one, to the last item. Okay, the next one, basically that's an empty slot. Okay, so when we implemented using circular array, we always maintain an empty slot in the array, okay? And we implement using array, so, and in this case, we consider an integer Q, okay, so, and we also define the capacity. So this is Java's constant. Okay, so not a lot of new things, is it? And for the constructor, be very careful. what the constructor does is, besides initialize both index, is it to 0? Here, because it's involved array, so you also need to create memory storage, is it for the array, okay? So never forget about this, okay? Generally speaking, when you define a class, if a class has reference type as its instance variable, then you do need to do the new, okay, to get memory on heap, okay, and associate that instance variable with that memory, okay. So that's what you needed to do here. And then let's see the enqueue. So for enqueue, you're going to add a item. So that's why you need to have parameter for the function, is it? And it belongs to set method. It's going to change the class. And of course, when we do the circular re-implementation, it can be full, is it? So the full condition, if you recall, is if the back index, you advance back to the next one, is it? So you increase. So you add one more to the back index, and then we do the module. So this module operation is for circular array. Okay, and for circular array is to do that wrap around. That then if both are the equal, then that means the queue is full. So we throw some exception, okay? Otherwise, you add the item at the empty slot, then you update. Be careful about the sequence, okay? You add first, then update. Update back index. You cannot do the other way, okay? That will not be correct. So that's how enqueue works. And then next, let's take a look at the dequeue. As a dequeue, we also need to take care of empty queue condition. So when queue is empty, that means both front and back index point to the same slot. It doesn't mean that both need to be at index 0, okay? Just the both need to be at the same slot. Then you just throw the empty queue exception. Otherwise, you update the front index. Be careful, okay? We need to always do the module, okay? To avoid that index out of bound problem, because over here we implement using circular array, so there is no index out of bound. We need to worry. So and for the front item, the return type should match the array, okay? But of course, we also need to take care empty queue condition, is it? So if the queue is empty, then we throw this exception, okay? Otherwise, you just get the front item, okay? So sub front. The empty is pretty simple, is that you just do the front and the back check. Okay, then next, let's see the toString, okay? For the toString, what we are going to return a string, And it's from the first item to the last item for the queue. Is it for the, so we need to loop our loop index start at the front index. So this is starts at front index. And it's terminate at back index. Okay, and when you do advance to the next, we cannot just do plus plus. Okay, so be careful here. You need to do module when you do advance to next. Okay, and then you just get a specific item. Okay, and we can append because we use a string builder. Okay, and then you convert to string. So this is pretty straightforward. Okay, what next? Let's take a look at the clone. And for this clone, we want to do deep copy. And deep copy because it involves an array for instance variable. So we need to create memory for the clone one. For the clone, is it? And then copy value one by one. That's how should we do it, is it? So in order to do that, we can create a new queue, is it? And the size depends on the existing instance variable array's size. Okay, so we declare a new queue. And then it's front index, back index, the same. Then we do item by item copy. So same thing, we start from front index all the way to back index. And when you do advance to the next element, you need to do the module plus plus, but remember do the module, is it? And then you do value copy. So here is value copy. And this new take care of the deep copy part. Okay, so now this is a deep copy, is it? Not a shallow copy, okay. Okay, so this clone is pretty straightforward. So this clone is regarding the clonable interface. Because our queue implements clonable interface. But be careful, okay, clonable interface is called marker interface. That clone method is from object. It's not from this clonable interface, or clonable doesn't have the abstract method. Okay, but why we still need to set this clonable interface? Let's take care of the marking business. Okay, what the next one is about iterable interface. Iterable interface, then you need to import this iterator, okay, library from Java. Okay, then let's see what this does. Okay, so that iterable interface, okay, iterable interface, so it is also a functional interface. So it has one abstract method. And that method, we need to implement it. So that method is called iterator method. And that iterator method returns an iterator. So the return type is called a iterator. Okay, iterator. And what iterable means? So if you recall previously, we are mentioning iterative, is it versus recursive? Iterative just loop one by one, is it? So iterable means you can do some traversing one by one, okay? And this one by one, so move from current location to next location. Is it to next location? So we call this advance to the next. Is it because we cannot always see plus plus when we do iteration? That's not always case. Is it sometimes we say, okay, we need to do some advance. Sometimes when you do reversing, it's back. Is that okay? So anyway, iterator allows us to do one by one visiting. We call it a traversing. Okay. So what it returns? It returns an iterator. Okay. So what is an iterator then? You may ask. Okay. Basically, an iterator is also an interface. So iterator allows you to advance. Okay, and it also allows you to do some removing operation, but it's an interface, but it is not a functional interface. Okay, that's regarding iterator, okay? So that's why over here, you need to return some object. Okay, so the object implements iterator interface. Okay, so that's the concept. Because you need to return that object, so we need to define a class. But this class is defined within of a Q class. Is it? So this class is an inner class. And we make it private because it's only available to Q class, okay? No third party can see it. Okay, it's a private class and it implements that iterator, and that iterator interface has three methods called has next, next, and remove. So we need to implement all three of them, of this methods, okay? And because we define a class, so we need a instance variable. In this class, it's instance variable, we name it as index, okay? Okay, so for this index, for this iterator, initially we started at the front index, okay, as fronting, and it has a method. So the iterator interface always starts at front, okay, at the very first, be careful, okay. And if you do want to move to the next, then we have two set of the method you need to call. So you have a method called has next to check if you already reach the end. Okay, if it is not, then it will tell you, okay, you haven't reached the end, in this case, the back, is it? You just do index plus 1. And be careful, because over here, we use a circular array. So that's why you need to do the module operation, okay? So that's regarding has next. And then the next. So what next? It will return the item. Return the item, okay? Basically, it returns wherever the index points to the item, okay? That's it. So you get that item, is it? You get that item and record it. After that, you advance the index to the next, is it? And we return this result. And we also need to, before we can go ahead do all of this, we need to check if it has next. Because if it doesn't, it will return false or return false. Then we need to throw exception, okay? So that's the idea about has next and next. And remove, we didn't implement, okay? We leave it just throw some exception, okay? And in this case, we don't, but we needed to implement for the real one, okay? So anyway, so for this is an inner class, and this inner class implements this iterator interface. Then this class will support you to check if a sequence, or we call it a container, has next item, and as well as you can get next item. Okay, so that's what this method or this inner class does. So then you return an iterator, as it here. Okay, and once we implement this iterator, that means you fulfill taking care of this interface. And this is a functional interface. It has that only method, abstract one. Okay, it's called iterator. That method will return you an iterator so that you can start to do one by one visiting, is it? So that you can do one by one visiting. Okay, so that's what this iterable interface here benefits us. Then you may ask, why do we need that? Let's take a look at the example, okay? So we already know that Q class, okay? So we are going to do some application on the Q. So in order to use Q, you need to create a Q object first. Okay, then we can check if it is empty. So you just call the respective empty function. And then we can add some elements here, okay? And then you can keep a call in Q. Okay, that's how you add a new item. So after we complete, we can output the Q. We can also check if the Q is still empty. And you can also check the front item of the Q, okay? And here we are going to take a look at the search method, okay? Anyway, the next part, so if you recall for stack, we also use this quite often, is it? So while we use while loop. So while certain condition, you provide certain condition, is it? So over here, what we are going to do is, okay, we keep do DQ, is it keep removing, okay? And in other operation, you can do something, is it? You can do front, and then DQ front and DQ. So a lot of time we also do this. We also do Q1 dot front, is it? And then DQ, and you keep doing. Then in this case, it will get item by item from the queue, okay? Okay, then let's take a look at this search method. Okay, and here we have two versions of search. So this is the first version of search. Search an item in the queue, okay, in the queue. So the first thing we do is we don't want to do operation on the queue itself, okay? So that's why here we do a clone. Because if you do operation on the queue itself, it will change the queue, okay? So here we don't want to change queue. If you don't want to change the queue, then you need to call the clone to have a deep copy of queue, okay? And once you have that deep copy of the queue, is it? Because you try to find something, then we need to one by one check. So you check the front with the item, and then you do the DQ, is it? You do the DQ. And if queue is empty, that means you didn't find the item, okay? So that's regarding this case. If we do DQ, is it? Then we change this queue copy, is it? So here, it may not be efficient, is it? Because think about it, you just want to find some item. If your queue size, queue is huge. Oh, sorry. So then if queue is huge, then whenever you do clone, it's too many copying work. So not efficient. Is it not efficient? So let's take a look at the search 2, okay? Then for search 2, did you see? If you recall, this is called for each loop. And previously, we saw for array and array list, is that we can go ahead to use, is it? And now for this queue, we can also use this. And why you can directly use, it's because iterable interface already implemented on queue. Okay, so if a class that implement an iterable interface, then you can directly go ahead to use for each class or for each loop. Otherwise, you cannot. Okay, then it's much easier, is it? Then we just need to do one by one visiting and compare. And then once you find it, you return true. Okay, so that's how this works. Okay, otherwise you cannot. And we can run this example and take a look. And then let's see, I will also show you, you will see the. And then so here it says, okay, how many items? Suppose I want to have 5 items. Then did you see, it will generate 5 items, is it? And we are each time if we remove item, the queue, the front item is going to be removed and the queue is empty, is it? And also we check if queue is empty, okay. And where did we do the search? Found item or not found? Oh, that's because if you recall, is it the queue is already empty, is it? So the exception is brought here, is it? When we try to do search, that won't work, okay. Okay, so that's regarding the queue operation. So next, let's see the exception, is the empty exception. So here we throw this queue, empty queue exception. So where that come from? If you take a look of a project, we have the queue, full queue and empty queue definition. So that exception is defined. So here is that empty queue exception. So basically it's a subclass from the runtime exception. It's a pretty simple class. You just inherit from runtime exception, is it? So you just create its own constructor. Then you call superclass constructor. So basically over here it's about, okay, that queue is empty, okay. And then let's also take a look at the full condition. So for the full exception, it's similar. It's also a subclass from runtime exception. And then when you implement, you just call that super, okay. Okay, so that's regarding this example, okay. So we do the search, we find, and then we just check, is it, when you remove off the item, the queue should be empty, is it? When the queue is empty, if you still try to get the front item, it will throw that empty queue exception. And then that empty queue exception. So basically here, because after we finish this loop, the queue is empty. And when queue is empty, if you try to call the front, if you recall, then it throws new exception. Is it? And that exception then is going to be called here. This is going to be called here. So similar here. Is it similar here? Whenever you want to dequeue, because it's already empty, is it? If you take a look here, yeah, both of this front, is it the front? Because when queue is empty, it's going to throw that exception, okay? And you throw exception and it's get called that in the try-catch block. Okay, so this is regarding regarding the first example. And the next one, and in Java, okay, Java also provide a queue, okay. So the next example on our course website is called Java generic queue, okay. This example. And for this example, we import 3 libraries. Okay, the linked list, basically this is a class. And the queue is an interface. Later on, we will learn generics, okay? And the iterator we already saw, that iterator is an interface, so we need to import it in order to use, okay? So let's see this example. So for the queue that we defined, it only applies to integer. Is it? So very specific. And if you recall, array list and the stack, we already use both of them. Is it? Each time if you want to use it, you can do integer. You can also do like array list string. You can also do array list like employee, is it? So you can plug in whatever the type, is it? And the stack, the same thing. You can plug a different type, is it? So that's how the queue works in the Java library. You can also apply it to different type. Then you just plug in this angle brackets and provide the type, but it must be reference type. Okay, reference type. And like previously I explained, the queue, it is an interface, not a class, not a concrete class. Okay, the linked list is a concrete class. Okay, it's a concrete class. So in Java library, whenever you want to create a queue, you can use a linked list, serve as the queue. But you take advantage of first in, first out of queue operation. Okay, so this queue interface, it provides you add at the back, remove at the front operation, and the linked list implemented it. So you can basically use linked lists operations to fulfill the queue's behaviors. Okay. So the operation for in queue, so basically it's called add. Okay, so in library, it doesn't have in queue. So add over here is equivalent to our in queue in library. Okay, so this is add at back. Okay, add at back. So keep this in mind. And then, where is it? Back here. Okay, if you want to get the front item, here is how you retrieve front item. You call the operation called pick. Okay, pick give you front item. And you can also call the toString. So it also supports toString operation. Okay, and next let's see this search method. Oh, where is that? Hold on, okay. I cannot find my, for some reason messed up everything. Okay, now it's back. Okay, it's here. And then let's see the search operation. Yes. Okay, So this time the search, is it? And what the search parameter is also the libraries queue. Okay. So over here, what we are going to do is, because a linked list, that clone is also not a deep copy. Okay, it's just a shallow copy. So in order to create a deep copy of our queue, in linked list, it has a method called add all. This add all operation, you can plug in a queue. Okay, then it basically does one by one copy. Okay, and also create a memory location at a new memory location. So basically this add all is just like the deep copy. Okay, and then we can do the search, is it? Okay, so how do we do the search? Is you do the loop, is it? You need to do the loop. If it is not empty, then this is similar as pick. So this element also used to get front item. Okay, you retrieve the front item, is it compare it with the specific item? Okay, so if both are not the same, then you keep removing, is it? And then finally, if the stack or if the queue is empty, if queue is empty, then that means the item is not in the queue, okay? If it is not, then it is in the queue, okay? So this is regarding the search, and it won't impact the original queue. Okay, so we understand the search. And what next one is for libraries queue. It's also very neat. Basically, we don't need to write our own search. It has a method called contains, and it will directly give you the result. Basically, this is similar as the search that we just wrote. Okay, so the contains method will also do the search for you. Okay, we can do that. Okay, and then what next one? Let's see. So the next part is a for loop, is it? But it is for each loop. Okay, and why it can use this for each loop is because that linked list class implements the iterable interface. That's why you can use, okay, otherwise you cannot, okay. Then you can retrieve item by item and it won't impact the queue, okay. So that's this part. And there is a second version of the for each, and this for each is a method. Okay, it's a method. And queue interface, basically here it's this linked list, also has this method for each. Okay, but within it, if you recall, this is what? This is a lambda expression. So you need to plug in a lambda expression here. Okay, so basically what it can take, it takes an iterator. Okay, something that implements iterator. That's what it means here, okay? So over here, it's just some item and some operation you want to do on that item one by one, okay? But anyway, you need to plug in with a lambda expression because what it takes is something of iterator. Okay, some iterator thing that can be plugged in, basically, or you need to create an anonymous inner class, etc. And because, oh, not iterator, I'm sorry, it should be iterable. Iterable interface, okay. Iterable interface. That's because then over here to implement that iterator. So that's why it can do that one by one visiting, okay. So it just shows us you can do multiple ways. And then later on, you may know why you say, oh, you already have this for each. Why do we need this kind of for each? That's because for the functional programming, design pattern, okay. Because Java now also support this kind of design pattern. And once you have this for, you can do the chained way, okay. Not like this, you cannot, okay. So basically it's just a single statement. But to fulfill multiple tasks. And also it's kind of in streaming way, kind of one by one, step by step. Okay, that's why it provides this operation. Okay, and we have a little bit of left with this iterator, so we run out of time today. So let's stop sharing here. Okay, so we